Let's discuss question number 8 from test 1. Let's read the question. An aluminum alloy rod 10 mm in diameter is subjected to an axial pull of 6 kN. Given Young's modulus 70 GPa, shear modulus 26.3 GPa, and what is asked is transverse strain in the rod. So this is from strength of material, so I'm just writing SOM. Okay, so what is given? An axial load is applied on an aluminum rod which is circular in diameter. The diameter is 10 mm. Okay, and you are subjecting it to an axial pull which is 6 kilonewton. So let's denote the load to be 6 kilonewton. Okay, so these are the data. This is the given data. Young's modulus is given as 70 GPa, and instead of giving Poisson ratio, he has given shear modulus. Okay, so let's first so transverse strain is asked. Now transverse strain is related to your axial strain by Poisson ratio. So let's first see the definition of Poisson ratio. Now Poisson ratio is minus transverse strain, that is strain in the perpendicular direction, to your axial strain. So this is basically the definition of Poisson ratio. Now we don't know Poisson ratio here, but now this negative sign comes because if the axial strain is positive and if you apply a tensile load, as this is the case, if you apply an axial load, the strain is basically, it expands, the strain is positive, and in the perpendicular direction it contracts, basically in the diameter direction it contracts. So basically the denominator is positive, the numerator is negative, and in order to make it completely a positive quantity, we have this minus in the definition. So now Poisson ratio, how do I get this Poisson ratio? Now you have E, you have G, so we have a relation among shear modulus and Young's modulus which is given like this. So from this I can get the Poisson ratio, which I am denoting here by nu. So G is given, E is given, and so I can easily find out nu. So nu comes out to be close to 0.33. if I just choose a calculator from this, nu comes out to be 0.33. So I know nu now, so I can easily find out transverse strain. Transverse strain is minus nu into axial strain. Now how do I get axial strain? Well, I can use Poisson ratio, I can use the Hooke's law to get this. Hooke's law. Okay, for a load, okay, when a load is applied, let's come from the basic. The stress is Young's modulus times strain, and this strain means axial strain. Stress is load per unit area. Young's modulus, this is my axial strain. Okay, this is what I want, so let's note it by epsilon. Okay, so basically I am using a Hooke's law here. So epsilon is P by AE. Okay, and then I have to, so basically my transverse ratio becomes minus nu P by AE. So this I'm doing in a, I'm just explaining each step, so that even if you know all this, you can put in a one step. So let's put this 0.33. Now load is given as 6 kilonewton, so 6 into 10 power 3. Area, let's put in pi by 4. It's circular, so pi by 4 d square, so it's in mm. So areas I always keep in mm square, loads in newton, so that directly you will get stress in MPa, and Young's modulus is given in MPa, so I'll just substitute in Young's modulus in GPa, I'll substitute in MPa in order to be consistent with this thing. Okay, so you have this mm square, and this is newton per mm square, which is MPa. So mm square get cancelled, everything is newtons, and you get transverse strain, which is unitless, and so the value comes out close to be minus 0.00036. So this is when you use a calculator, and therefore looking at the option is A. Now remember, this minus sign is important because when you are pulling here along the axial direction, the strain increases or the strain is positive, and in the other direction it contracts, so there has to be a minus, and that has come from this definition. So the option is A. Thank you.